My name is Brian Chidora, and today I will present my activity 8, which is acid and bases. Objective: to become acquainted with acid and bases, particularly their properties, to know whether acid or bases exist in all liquids that have an ionic component. What is acid? An acid is a molecule or ion capable of donating a proton or creating a covalent bond with an electron pair in the case of Bronsted-Lowry acid. The proton donor, also known as Bronsted-Lowry acid, are the first group of acids. What is base? A base is a chemical that reacts with hydrogen ion to neutralize an acid. The majority of bases are minerals that generate water and salt when they combine with acid. Metal oxide, hydroxide, and carbonate are example of bases. Alkalis are water-soluble bases. An alkali is sodium hydroxide. Types of bases. Strong base is a substance that can remove a proton from an extremely weak acid. In water, they totally disintegrate into its ion. Potassium hydroxide, KOH, and sodium hydroxide are two examples. NaOH. Super base. When compared to a strong base, these bases are better in deprotonation. The conjugate acid in these are extremely weak. They are made by combining an alkali metal and its conjugate acid. Because it's a stronger base than hydroxide ion, it cannot survive in aqueous solution. Sodium hydride, NHA, and orthodiazenyl benzene dianon C6,4HC222 are two examples. Neutral bases. It forms a bond with a neutral acid, share an electron pair. Solid base. It is active in solid form. Example are silicon dioxide and sodium hydroxide mounted on alumina. Difference between acid and bases. A basis is an aqueous solution that releases hydroxide OH ion, contributes electron, and receives proton. A proton donor is an acid. A proton is accepted by a base. Acid have a pH value of 7.
Tiny bite of a piece of fruit to the caustic liquids used to clear a clogged sink, acids are a type of chemical that can be found in many different aspects of our daily lives. But what is it about acids that makes some safe to eat and others dangerous? When talking acids, we're going to be talking hydrogen. Not the gas, but rather the hydrogen ion H+. This is a hydrogen atom that has lost its one and only electron. All acids produce H+ ions when dissolved in water, but it's how much H+ a specific acid can produce in water that will determine whether it can be safely eaten or not. But how do we conceptualize and measure H+ concentration? Søren Sørensen, a Danish chemist, pondered this question when he worked at the laboratories of a commercial brewery in Copenhagen. It was in 1909 that he developed a method of quantifying acidity, what is now known as the pH scale. His scale works by simply converting the concentration of hydrogen ions in a solution to a number between 0 and 14. If a chemical is acidic, then its pH will always be below a 7 on the scale. The lower the number, the higher the hydrogen ion concentration. The pH scale is a logarithmic one, meaning that 1 unit difference on the scale, say from 3 to 2, means a 10-fold difference in H+ concentration. But 0 to 7 is only half of the picture. So what about all these numbers above 7? Substances that correspond with this half of the scale are called bases, and they are the chemical opposites of acids. The 7 on the scale represents neutral pH, what would be perfectly pure water. Like acids, bases are found in chemicals that we encounter in our everyday lives. Cleaning products such as ammonia and baking soda are bases, as are some simple medicines like milk magnesia. They're bitter to the taste and often slippery to the touch, kind of like soap. Even though bases are different than acids, they too can be strong or weak, and a strong base can be just as dangerous and corrosive as a strong acid. Chemically, the difference between acids and bases is that acids produce hydrogen ions and bases accept them. In water, acids produce H plus ions and bases produce OH negative ions. In reactions between acids and bases, hydrogen ions will react with hydroxide ions to make water. This type of chemical reaction is called a neutralization reaction. Acids and bases are also very important in biochemistry. Many biological processes are sensitive to the pH of the surroundings, so controlling acidity in the body is crucial. Some biologically important molecules like amino acids have dual personalities. They're said to be amphoteric, which means that they can act as both acids and bases. An amino acid has a carboxylic acid group that can produce hydrogen ions and an amino group that can accept hydrogen ions. Acids and bases are all around us and can vary greatly in terms of their use and their nature, but they all involve hydrogen ions being passed around.